यार VS कोड चला तो नहीं पर दिक्कत आएगी।
Good evening, everyone. I welcome you all in the mentoring, come doubt solving session of Code Heist Week 1.
Yeah, I just wanna be great. 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 Yeah, I just wanna be great.
कोई नहीं, मत करो हाइड।
A very good evening, everyone. I welcome you all in the mentoring come doubt solving session of Code Heist Week 1. I'm delighted to say that Code Heist Week 1 was a great success with more than 1300 registrations and 1000 plus participants competing for the win. We are well aware of the issue which many of you faced yesterday. We are closely working with Dare to Compete on all issues. And don't worry, in case the issue persists, we will manually evaluate your code. All the codes that were in compiling and queue would be considered for the evaluation. Today we have Aryaman Jan sir with us to help us with the questions and doubts. He is very well versed with DSA and competitive coding. Aryaman sir, you may please proceed.
Hello everyone. I'm Ariman Jain. I'll be doing mentoring session today. So before getting started, let's just do a little poll to see where most of you like having doubts. So just do a poll about all the questions, and anyone if having a doubt in that question, just ping it. Okay. Moderators will soon make a poll, so just wait. Until then, if anyone have any specific doubt, they just ping in chat before uh, before explaining any question. I can just look over those. You're talking about which question? Can you be a little specific? Tushar? Question 1 in Division 2. So question 1 is Division 2. I think it was this one, right? Tamari was organizing an event on big ground for New Year, and you have to find the imposter, right? Okay, I'm assuming this is the question. So I just sorting and checking. Okay, so I think the complexity for the test cases was 10 to power 6, right? The n and t was 10 to power 6. So if you do sorting, it will be n log n. So for n log n, what you are doing, you are running about like you will do 10 to power 6 iterations and few iterations more. So when I will create a specific test case, then the sorting won't be enough to run that whole code under a second or under a second. Okay, so that's why this question was need to be solved in a complexity of linear complexity and complexity. So it's what a very simple solution. Let me explain it. So basically, the trick was Uh, just a sec. Okay, yeah, let's. Okay, so the trick was each element have a couple, right? So like one will have a couple, and a imposter will be the only element which will not have a couple, right? So we can use this property, very specific property, to take advantage of this. So what XOR does? So XOR. So what XOR does? So what is the like table for XOR, right? So for 1 1 we will get 0. For 0 and 0 we will get 0. For 1 and 0 comma 0 comma 1 we will get 1, right? So basically if you look closely, if the element is same we will get 0, and if element is different we will get if the element is different we will get 1. So the bitwise operation has a benefit. Now how it doesn't matter how in which order we did it, right? So like if I did one XOR 0 XOR 1, or 1 XOR 1 XOR 0, it won't create a difference. Okay, so now what we can do, right? So like if I did a XOR of all those elements, right? So the couples will be removed, they will be 0, and the imposter will be left, because the XOR for imposter can't be 0 because there is no couple for it, right? And the for any element, you can see if we do XOR with 0 we will get the same element, right? So if we did XOR with 0 we will get 0, and here also we did XOR with 0 we will get 1. So what will happen? All the couples will be removed because those XOR will be 0, and only the imposter will be left, because 0 XOR the imposter's ID will be 3. So if, let me code it. So I'll run it for a single test case, right? Because in this we will run for multiple test case, right? T, but I won't do that. So I will do int n, then it will be int x is equal to 0. Okay. Just a sec. Yeah. Okay. So I can take an input. I can create a temp variable. I need a temp. Now temp is like taking this each numbers ID as input. Now what we need to do, we need to XOR with the current storage, right? So we will using X as a storage of XOR of all the previous element, and do XOR with that, right? So X is simply is equal to X XOR temp. Okay, so what we will do, we are just doing XOR of all the elements, and basically all the couples will be removed and only the imposter ID will be left. So we can check it out. Let's see how it. Okay. So let's do SDN. Let me do 5. Let me do 1 1. Let me take this only. 4 couples, right? 4 and B. So and this. Uh, okay. So what did I do wrong? So same time, same time. Oh shit, my bad. So we are taking number of couples as input, so it will be into 2 plus 1, because there are n couples, so there will be n into 2 peoples, and there will be 1 imposter, right? So we have to take this as input. So let's execute this. Right, so we got 3, right? So I think imposter was 3 here. So we can just check it out this also. Like let's see out X and DL. Okay, so let's see this also. And let me take this and paste it here so we can check it live. Okay, so what we did, so first we got 1, so XOR with 0 we got 1, then we got again 1, and so it like we get the second element, right? So it becomes 0. Now we did XOR with 5, so 0 with XOR 5, then we did 5 XOR 3, so it becomes 6, then 5 XOR 2 become 4. But now we can see like all the elements, we will see a pattern, right? That we will get 5 again. Basically all the couples will start removing, but first it will be added, then it will be removed, and only the imposter will left, because it's a single element and there is no identical element for that whose OR will become 0. So let's move on to next question. So this question is clear, right? Tushar, is this question clear to you? That why didn't we do sorting, and why need to, like, why need a better approach for that? Because sorting is it won't be enough. Okay, great. So anything else? I'm waiting for division to questions because I think moderator did the poll. I'm waiting for that, and the question with most vote, I'll explain it. Okay. Okay. So greedy. Okay, division one. There's a lot of majority in division. Okay, I'll look into that. Okay, so rare antiques have a good amount of votes. Okay, let's see. So the problem in rare antique was like Baldwin was doing a different option. There are different IDs, right? And we need to find the pairs whose sum is equal to a given number. Now, this question can have two types, but in that, I think in the question it was specified there will be distant element, which is a key to making a very simple problem. Because for distant elements, we don't have to look for the, like, if element is repeating, we don't need to count it twice or thrice. Okay, so we just need to count element once. So if we count it, then we don't need to check it again. So we can take advantage of this and make it much simpler. So let me take this example only. So let me just copy and paste this. Okay. So this was the test input, simple input. Okay. So what I was saying before. So if like this was the case, like there might be repeating elements. So we need to count. Let's say yeah, here it's 5, right? X is equal to 5. 5. So one pair will be 1 and 4, one pair will be 3 and 2, but we can use this 3 also, right? So we need to count it twice. So that's why when it's just an element, we can just get over with an element and we don't need to count it again. Okay. So let's see. Okay, so this was a problem. Now what we need to do. So if like if we add two numbers, like let's assume there is a number a and b, okay, and it is equal to some number less than x. Okay, some number less than x. Okay, so what we need to do, we just need to somehow increase this, right? and we need to increase one element, right, a or b, to make it equal to x, or it might be greater than x, but we need to increase one element. And if it's just opposite the case, like a and b is greater than x, we somehow need to decrease one of the element a or b, right? Now what we can do, we can take advantage of this, and what we can do, we need to somehow check that we know if I do something, then this element will be bigger than before. There is no possibility that it's just bigger than the previous element in the array. So we just need to like check like which is the next biggest element in the array to 3, which will be 4. What is the next biggest element in the array? 7. Okay, we need to check this. But if we do it again and again, it will be very high complexity, right? So what we can do, if we sort it, so what will be the sorted version? We will be 1, 2, 3, 4, and 7, right? So this will be the sorted version. Now if we sort it, what we can see, the next biggest element will always be the next index, right? And the next smallest element will be the previous index, right? So if just a sec, let me see, is there any query? Okay, you did it by binary switch. Yeah, that can work it out also, because it's n log n, it's sure work out. Okay, so yeah, so okay, there is nothing. Okay, let's go proceed. So now now this I've sorted this. Now x is equal to 5. Tushar, you're talking about this question, right? This question only. You did it with binary search. Okay, so let me proceed. Okay, so x is equal to 5. Now if there is a and b, now if we need to decrease and increase a and b, we know we can just go to the previous index, and if we want to decrease, we can go to the next index. So what I can do, I can take 2 pointers, okay, and keep it to the smallest element and the biggest element. Okay, so now a and b is 1 and 7. 1 plus 7. Now we know 1 plus 7 is greater than 5. Okay, so we need to somehow decrease it. Now increasing this index won't make an effect, it will just increase the sum because we are going to a bigger element, but this will make it. Okay, so we can just go to the previous element and we can check this. So okay, my mistake, 4. So what we did, we checked the previous element, now it's 4. Okay, so now it's is equal to 5, right? And we can just take a count, increase the count, that now okay, this pair worked out. Now this pair worked out, right? Now we don't need to increase or decrease, but we need to check other pairs also. Now we can either increase this pointer, or we can decrease this pointer. We have both options, right? But we can do either one, it won't affect, because we are, if we decrease it, we will decreasing a and a plus b, and if we increase it, we will be increasing a plus b, and eventually it will be similar, because we have to first we will increase it, right? Then the sum will be greater than 5, right? So we need to decrease this, so we will come back to the same point, either decrease or either increase. But if we have a different, if we have a same I talked about, if we have a same elements, right? So if we have 1, so if we decrease it, we can't now decreasing and increasing will make difference, right? They are not the same case, because if we decrease it, it will be to 3. Now the sum is 1 plus 3 less than 5, and we have increases 1, right? Increases pointer. Now it's still less than 5. We have at the pointer at 1, pointer at 3. It's still less than 5, but we miss out a pair, right? We miss out this 1 with this 4. So this solution won't work if they are repeating elements. Then we have to use maths. If there is a majority of people who want to see the solution for that question, and if there is a repeating element, how we will do it? Like we can, I can explain that also. So let's just assume there are distinct elements. Okay. So now we can either increase or decrease. So let's decrease the pointer. So now at 3, now it's 1 plus 3, which is less than 5, right? So we need to somehow increase the sum. So we will increase this pointer. Now it's 2 plus 3, which is equal to 5. Now we have total 2 pairs that are equal to 5. and then we can increase or decrease. The pointers will be at the same element, and we have just look all the elements, right? We have started from the far ends, and we have met a point where the elements intersect. So we have looked all the elements. So now we have found all the pairs whose sum is equal to 5, right? Okay, so which part I need to repeat? Can you please, Shrimant, please, uh, I'll repeat that part. Can you mention it, chat it again, please? First sums or okay, okay. This is the previous question, right? Okay, I'll explain it afterwards. Uh, Let me just first finish this solution. Okay, then I'll proceed to that. Okay. So now we can use two pointers. So let me just create a code for this. So we need to create a vector. So vector is basically an array, extend dynamic array, so we can change the size of it. But we know it's of n size, so we can use it. So we have n, we have x, and we have number of elements. So I can use x. I can take this as input, and for int I is equal to 0, I less than n, I plus okay. So here we go. So we have taken all the inputs, right? Now we can proceed. So we can, what we did, we created two pointers, one at the starting end, we created another at the last end, and we did the checking thing till both pointer will intersect. So basically, when the first pointer is before the second pointer, basically. So we can repeat this process. Now we have three cases, right? If vi plus vj is equal to, okay, let me do this, is equal to x. So we have this case. So for right now, let's just do this. Now we have another case, it's less than x, and another case is greater than x. And if one of the case, so the other won't work, so we can just do else if here. Okay, and we don't need to else if here because we know it's less than x. Okay, so these are the three cases. So the first case, the both element, the sum of a and b is equal to x. So we just need to increase the count by 2. Then using 2 because we know found the number of rare antiques. We can, if there was a number of pairs, we just can do count plus 1. And we need to either increase or decrease the j. So I'll be decreasing the j. Let me just create count here. So count is equal to 0. Okay. Now the second case, when the sum is less than x, so we need to increase the sum, and the I is the next index of the I will increase the sum, right? So we will go to next index of I because it will increase the sum. Like this, it's like moving this pointer, the first pointer to the next element. And now the third case, when the sum is greater than x, we need to decrease a and b. So we will be, it's like moving this pointer towards left. Okay. So there are three cases when the sum is equal to x, when the sum is less than x, and sum is greater than x. You can just change the count, and we can check this. Okay, so 1, 3, 2, 4, 7. Okay, we missed one part. We need to sort this because we need the sorted array for this. Okay, and we dot and okay, yeah, this should be good. So I think the input is 5, 1, 2, 4, 7. Okay, so this execute. Okay. We are using vectors, that's why I need to It's a basic library which consists most of the standard templates. Okay, like one of them. So like we get it right. The four. So there were four pairs, right? One and four, three and two. So we can just change the test case also, and we can see we can add uh, 0 and 5. We can add what we can else add. We can't add repeating elements. So let's make it 10. We can add 6. We can add 8 and 0. Okay, let's see. So 3 or 3, 6, 6, 7, 8. There are 8 elements. We can execute this. Let's check 1, 2, 3, 4, 5, 6, 7. Okay. There is 0 plus sum is equal to 8. 4, 6, 8, 1, 6, 3 or 3, 6, 7, 8. Yeah, it's right. Oh, my mistake. I was sorting before taking the input, so I have to sort after taking the input. So 6. So we can check out. So there was one pair 8 and 2, one pair 6 and 4, and 7 and 3, right? Yeah. So we can do one more thing. We can do it 9. Then it should be 8 now. We can check. Yeah, it's 8. So anyone having doubt in this? Or should I take the doubt of MVS Srimant? Okay, I think there is no doubt. So I'll be taking doubt of Srimant. So Srimant, your doubt was with the XOR problem, right? So what is the property? So basically, what we did, we are using exploiting the property of XOR, that the XOR of similar elements is 0, and XOR with 0 is always that element. So when we have the case that there are multiple repeating elements, and we have only one element which won't be repeating. Okay, just let me 2, 3, 3, 4, 2. Okay, so here is 4. So when we have a case where all the elements are repeating, just leaving one, what we can do, we can XOR all the elements, because what it will do, it will just remove the repeating elements, because the XOR of similar elements will be 0, right? It will remove all the similar elements, and so all the similar elements XOR will be 0, and we will be just doing the XOR with the only element which is not repeating. So we will get the element which is not repeating, and here is the imposter in this case. So, and why it's like, why the order doesn't matter, because we are doing bitwise operation. So we do 1 or 0 and afterwards 1, or we do first all the ones then 0. It doesn't matter. So that's why we can just XOR all the elements, and we will find the unique element or the non-repeating element, because we are using the property of XOR, that all the similar elements have XOR 0, and the XOR with element 0 with XOR with a 0 will go at that element only. So Shimon, it's clear, right? So if it's clear, Srimant, I think there is no reply. So let me see any other query. I think there is no query. So there is greedy manager division 1. So I'll look into that before going to that. Okay. Before ending the session, just look into greedy manager. So okay, so it's clear. Okay, nice. So the greedy manager was okay. The greedy manager. What was this problem? One was hostages and one was greedy manager. Okay, I think greedy manager was this one. Okay. So okay, let's understand what is the question, because it's little twisted. His previous question was little straightforward. So the question was, you are the resource manager and you need to manage code, and you need to fulfill everyone's need. So there is everyone's have a need of either taking a gold or giving gold. So -2 was they need gold, and 4 they were giving gold to you. Okay, so there are a line of people who are either giving the gold, and this is the same thing. But now here case, you are greedy, so you decided to get maximum profit. So you decided to skip people. But as you under surveillance, once you start accepting request, you can stop only once, and you need to take at least one person. So what this represent? We can skip people. So let's assume there was no surveillance. So for us, what will be the best case? What will be the best case? We can just take all the gold, right? So we can take all the person who are giving gold. We can just skip all those people who want gold and just take those person who are want to give us gold. But this specific condition make it difficult. That because once we start accepting, we can stop only once. So what does this mean? So like I want to skip few peoples, but once I start accepting, I can stop only once, right? So let's assume I start accepting from here. So I can't stop and then start accepting again, right? So let me take this case and paste it here. Okay, so this is the. So we have now the problem is like let's assume there are more minus here, -1, and here it's 2. Okay, and 3. Okay, so what I did, I skipped this, and I start accepting for here because I think, oh, it's giving me gold. I start accepting here, but I see this person want to take gold from me. I won't stop. I will stop taking. But once I stop, I can't take gold from this person also too, because it's mentioned you are under surveillance. Once you start taking or giving anything, once you start accepting that request from that person, you can stop only once. Like once you end here, you can't. You have to skip all the people after that, basically. So you can skip the people in front. You have to accept some people, and then you have to skip the rest of it. Skip the rest people. So what we can say, you have to skip X people, yeah, then you have to take A peoples, then you have to skip X B people, let's take Y peoples, and X and Y can be 0, but A can't be 0. Because A can't be 0, why? Because it is mentioned here you need to take at least one. So A is greater than equal to 1, X is greater than is equal to 0, Y is greater than is equal to 0, and same goes for X. So we have to skip X people, we have to take A people, and then we have to skip Y people again. Okay. So basically, we knew it should be a continuous part, right? So what does it mean? Accepting and stopping once means it should be a continuous thing. So we can accept this and then we can stop. So we need a continuous sub array. Basically, we need a continuous sub array whose sum. So sum by sum, because if we are taking 4 gold, 3 gold, and then we are giving -1 gold, -1 gold, basically we are accepting those all requests. So basically the sum will be the last profit. It could be the negative, it could be the positive, but sum will be the last thing. So we need to find out somehow a sub array whose sum is maximum, a continuous sub array whose sum is maximum. So this problem is reduced to a very well-known problem, maximum subarray, continuous subarray. So now we can solve this. So now how can we solve this? Okay. Excuse me. Okay. So let's proceed. So one thing is we can see, like if we are like let's start accepting from start only. Okay, we are assuming I am accepting from start. So it's -2. Okay. So I see that if I accept this person, I won't get any benefit, right? I'll lose load. So I'll skip this. If I accept this person, I will lose load. Let's do -4 here. Okay. Okay. -4, and let's do one more thing. Let's create one here. Okay. So I see taking one gold. from him, it's beneficial, so I take this gold. But now I'm giving mine 3 gold, so I have minus 2 gold basically. So I see if I take this whole, it won't benefit me, right? But I know this will benefit me. So this was my maximum till now, right? But if I take this if I take any sub array from this, it won't benefit me because it's like the profit is less than 0. So why I will take this part? So I will stop it from here. I'll start checking from here. So it's 4, so it's benefiting me now. It's 2, it's still benefiting me now. It's minus 4. So I have 4 profit, 2 profit, and then I have minus 4. So I have basically 6 minus 4, which is 2. But I'm still not losing, right? I'm still gaining something. So I can check if there is something further which will increase my worth, right? Previously, we can't do this because see here the sum is minus 2. So whatever we do anything ahead, so this sum is like if we start accepting from here, this sum is for sure greater than 0, right? It's minus 1, it's I think 7, 7, it's 4, right? So it's 4. But if we remove this part, because this part is negative, right? This sum is negative. So we can just ignore this part, and this sum will for sure be greater than accepting this whole part. So whenever we are dropping our profit from less than 0, we will look for another continuous subarray, basically. Because we know taking this part will further won't make an effect. Because always that subarray will be greater than this subarray. Because this is negative thing. But in this case, it's still positive. So there can be a chance we are getting elements further because this is positive. So it's positive plus positive, we will get something more. We won't get less. So we can look further that if is there any element still ahead that can benefit us. So here here sum was 2. Now sum is 5. We do minus 1, then we have 3. Still it's positive. Then we can take 2. And now we have this subarray with a sum of 2 to 0 minus 4 5 basically. Okay, now what we did, we found this subarray, but there is this, if we just accept this part, it was the most benefit part. So while we are looking for while we are increasing our subarray, we just need to store, is this is the maximum sum or the previous was one the maximum sum, right? Like in this case, like 6 is the maximum sum, right? If we end it here, let's assume this is the array. So my current max is 6. I can get more in future, but my current is 6. So that I was hoping that my sum might increase than 6. So I got here, it was 4, which was max till now because the previous max was 1. So I stored it. Okay, my profit is max 4. I get 6, so now my max profit is 6. I get minus 4. So I'll take that my max profit is 6, but currently my profit is 2, and it might increase in future. So I'll remember that my profit is 6, but I'll look further. Is there anything in future that increase the profit more than 6? Then I will store it. Okay. So what we will do, let's implement it. Then it might be more clear. So just a sec. I think it's greedy manager, right? Okay. So okay, let me remove this all stuff. We're taking this vector. We don't need to sort it. We don't need to sort it. Sort it will change the order. It won't affect. We just need to iterate. Okay. We'll be needing few things, which is the answer max till now. So max is equal to int min, because our profit can be negative. So that why we're taking the most negative number in the C++, which is int min. Now we have second thing, we have sum till now. What is the sum till now? The sum till now, and I think that's it. So sum till now is 0. So for int I is equal to 0, I less than n, I plus plus, or we can just do I in v. This is basically iterating over all v. Now sum till now plus is equal to vi. Okay, basically I. Now sum till now is equal to I, and a max can be either this current max or sum till now can be our max sum till now. Okay, so what we did, we're doing a max of current max and what is the current sum basically. But we are checking one more thing, right? That if a sum is less than sum till now is less than 0, we don't need to count it, right? So what we can do, if sum till now is less than 0, we don't need to count this part. Basically we can do sum till now is equal to 0 because we just ignored that whole part, and we can just take this part. Now there is a little small thing which will make a lot of difference. So what we can do, we can check this thing here also and this thing here also, right? We can check that if until now less than 0, we should ignore it before checking it is a max or after checking a max. But how it will make a difference? It will make a difference if we check afterwards. We have somehow checked one element or something. So let's assume all the elements are negative, right? -2, -3, -4, -5. So in this case, we are first checking the sum till now will be -2, so it will be negative. So the max can be a negative number, right? And then we are checking that sum till now is less than 0. But if we do this, so what we are doing, we are taking at least one element before checking any max. We know that sum till now has some element, right? Because we are nullifying afterwards it. So currently we know every time when we are checking max, sum till now would have something inside it. It will be known to be 0. It can be 0 basically. The sum of the sub array would be 0, but basically the sum of the array of the sub array length is greater than 0. Basically, we know this. So this causing using this, what we are ensuring that it has at least one element in it. But if we do this, what is this? We are not every time sure that if it has some element or not, because if it is negative, we are just ignoring it, right? So the sub array will be, this length of sub array will be 0, which we are assuming that the max, this is array max in giving maximum sum, its length is 0, right? So we are not sure that it consisting of some element. So what this will does, because it's like the maximum sub array here will be ignoring all the elements, right? Then we will get 0, right? We can just ignore all the elements and we will get 0. But doing is this is like we have to take at least one element. We have to take at least one element before checking it. Okay, so now we can see what our max is. So max, if we run this test case, so it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12. So we can execute this and our answer should be 6. So yeah, we get 6. So we can do one more thing, we can do -4. So we can do -2 here, and our answer should be 4 plus 3, 7. And yeah, it should be 7. And what if we do, if we remove this element and do it here, it should be 8. What we did, we have 4 plus 2, we check this part, it's 6, -2, it's 4 plus 3, 7. So we're checking future, still checking future. So max till now is 7. Then we did -1, which is 7. And then we is plus 2, which is 8. So max till now is 8. So the maximum answer is 8 here. Okay. So using this thing, we can find out what is the maximum continuous subarray. And using this, we found out what is the maximum profit we can get at starting once, accepting starting request, accepting once, and stopping once. So here we go with solution. So any doubts in this? Okay, sorry, I was not able to see the full screen. So my bad on that part. So if any issue is caused, I'll explain it again. So you can check. Is there any doubt? Still doubt? So if there is no doubt, we can wrap up the session. Let me look, just look. We can wrap up the session, right? There is no doubt. Just 1 sec. Moderators, there is something else need to be handled. Is there any doubt in Google Forms or something? We can look over it. Okay. I think there is. We can wrap up the session. So, Arush, go ahead. You can wrap up the session.
Well, that quite sums up our session. But don't worry, if you still have some doubts, we have already arranged another an after session with Aryaman sir only, in which you can interact, one-to-one interaction is possible. You can join the session via link. The link is in the description and in the chat section too. And also for your convenience, all the solutions of the questions will be posted in our GitHub organization. Please join our GitHub. The link is again also in the description. And once again, I would like to mention that we are well aware of the issue which many of you faced yesterday. We are closely working with Dare to compete on all issues, and don't worry. In case the issue persists, we will manually evaluate your code. All the codes that were in compiling and queue would be considered for the evaluation. See you all in the next contest next week, 26th Jan Saturday. Thank you.